given this function, p of x, write p in factored form as a product of linear factors. Be sure to write the full equation, including p of x equals, okay. So it's basically the same thing. Factored form really means you need to find the zeros. Factored form means x minus 0, 1, x minus 0, 2, and x minus 0, 3. That's basically what we're going to write. We're going to write p of x equals x minus 0, 1, x minus 0, 2, x minus 0, 3. So we just have to find those three zeros and put them behind a minus sign and an x in parentheses. That's what we learned earlier, right? That the roots, they're called roots or zeros, whatever you want to call them, either one, roots or zeros. They go behind, a minus sign, x minus each zero in the parentheses. So let's find them. How do you begin? You got to graph it. You've got to graph p of x at geogebra.org. All right, so let's go do it and find 1, 0, at least 1, 0 on the graph, just by looking at the graph. So let's go out and look at a graph and see what we can see. So I'm going to switch over and go there. Okay, and go to GeoGebra. I'm going to type in a new function here. It's going to be, what's the new, x to the third, so x up arrow 3, then right arrow plus x. Again, to do powers, you got to hit shift up arrow, which is shift 6, 2 power. Now I'm up here in the power zone. Anything I type is in the power zone, so I got to get out of the power zone. I go right arrow to go back down, or tab or right arrow to go back down to the main line, plus 4x plus 4, enter. There it is. It's graphed. So you can see the graph. It looks like it only has one real zero again, huh? Right here. What is that point? Oh, it's a -1. I just kind of focus in a little closer. Let me click on. You can click on it to make sure. Yeah, it's at -1. So it hits the graph at -1. That's the only real zero we can see from the graph, -1. All right, let's get back to work over on the iPad again. Okay, so now we found x equals -1 is the only real zero. The other two are going to be imaginary. So, okay, so what does that mean? Now you do synthetic division, right? Because you know one thing that divides in. That's what we're saying. We know one of these things automatically is x minus -1. That's the first zero. So basically, if we divide by x minus -1, we'll find an expression for the other two. So that's why we do synthetic division next. We divide out this term so we can get the other two. That's why synthetic division works. Okay, let's do it. Let's step 2 over here. Synthetic division, so you take that, which you've been given, the -1, put it there, and then right here we're going to grab all the coefficients. This is 1, 1, 4, 4. So let's bring these down. 1, 1, 4, 4, and we can put a line here because that's going to be remainder 0 at last spot. Okay, so we're dividing. We're using synthetic division here. We're dividing by the 0 we found. So bring this down 1. Remember the way this works, and then you multiply. Put the answer right there. Multiply -1 times 1 is -1, and then you add these guys up. And that's 0. And then the next one. -1 times 0 is 0. Add them up. 4. And one more time. Multiply -1 times 4 is -4. Add them up. 0. Of course, you should always get a 0 remainder. Always check. Why? Because you're dividing by something you know goes in. That's what it means to see it on the graph. It's a 0, meaning dividing by x minus minus 1, dividing by, putting the minus 1 out here, it will go in perfectly. It is one of the factors. It is one of the things that goes in perfectly, 0 remainder. Okay, so what's left? So basically we're saying the function f of x is x minus the first 0, which we already found is -1. This is 0, 1, the first 0. And what else is it? Now we know it's 1x squared plus 0x plus 4. Is that good? How do we know that? Well, we just took the function f of x and we divided by x minus a minus 1 when I did this right here, which is like taking this and dividing by x minus minus 1. This is gone. This is what's left. That's what's happening right now. This is what's left. So we've partway broken down f of x. Now we have to break this down. How do we do it? Quadratic formula. So now we go to the quad. We grab these coefficients. So I'm going to say this is A, B, and C. Let's go to the quad. -b plus or minus square root b squared minus 4ac all over 2a. You know the quad, I bet, pretty well by now. Okay, so -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's grab the stuff. A is 1. Wait, well, B. Sorry, B is 0. So this is 0. This is 0. A is 1. C is 4 over 2a, and a is 1. Huh, that's a weird one. So we're going to get -0 plus or minus the square root of 0. 0 squared is 0. Minus 4 times 1 times 4. That's 16. All over 2 times 1 is 2. So that's 0. Minus 0 is just 0. Plus or minus the square root of -16 all over 2. Remember what negatives inside of a square root do? They just throw out an I right away because they're imaginary. You can't take the square root of a negative number. It's impossible. What times itself is ever negative? Nothing real. So that is 0 plus or minus I square root of 16, right? The negative is gone. It came out as an I. So then what is that? That is 0 plus or minus 4i all over 2, isn't it? And you don't need that 0 in the front. It's just plus or minus 4i all over 2. 2 goes into 4 2 times. It's plus or minus 2i. There's the other 2 zeros, plus or minus 2i. So we got it. All the zeros are, what was the first one? It was -1. -1. And then the other two are plus 2i and minus 2i. But they want it factored, right? They want it factored. They asked for that. So factored, remember what it is? Right up here, we said it's going to be p of x equals x minus 0,1, x minus 0,2, x minus 0,3. So it's going to be p of x equals x minus 0,1, x minus 0,2, x minus 0,3. So let's write that. P of x equals x minus, x minus, x minus, and 0,1, -1, 0,2 plus 2i, 0,3 minus 2i. If it bugs you, you can make this x plus 1, x minus 2i, and x plus 2i, right? Because the double negative is positive and the double negative is positive. Don't forget to put the p of x in the front. They said that specifically. They want you to write p of x in the front, just like that. They want the whole equation with the p of x in the front. There we go. We just factored down that function. It's kind of weird, huh? That means that whole function, this whole p of x function, p of x actually equals x plus 1 times x minus 2i times x plus 2i. We were able to take this x cubed plus x squared plus 4x plus 4 function and break it down like this. If you actually FOILed all this out, multiplied all this out, it would go back to be the x cubed plus x squared plus 4x plus 4. All of this is the factoring, the breaking down of that function. So that was interesting. How did we do it? We graphed it, found the first zero off the graph, and then put it out here. And then we did synthetic division. We divided that one out to find what remained, did the quadratic formula on that part. And so we've got our final answer right up here in factored form.